Okay, so, all right, take a look up here, guys. Take a look up here. So it turns out, as we've been studying polynomials, we learned how to classify them. We learned how to add, subtract them. We learned how to multiply them. Now we're going to learn how to analyze their graphs. Okay? So the first thing I wanted to establish is, how do you know a function is even or odd? Okay? And we're going to talk about what I mean by that. You always look at the degree. Okay? So, and there's two situations that you can have, okay? Right, scenario one. Scenario number one. You got an even degree. Okay? So what do I mean by that? What if I have an even degree? What's the exponent going to be? Either 2, 4, 6, 8, 10, 12, and so forth, right? So it turns out that if I have a poly that has an even degree, the graph has n behaviors in the same direction. So either it's going to end up going both ways up, or they're both going to go down, okay? So what we need to understand, if you have this scenario, the n behaviors go in same direction. That is important to understand. So let me show you an example of that. Okay, I'm going to type a polynomial in our graphing calculator, and I want you to notice what it looks like. Okay? We do a lot of this in algebra too. Alright? But what we're going to do is we're going to say, alright, go to the y grid, and let's just type in x squared. That's an even degree polynomial. Okay? And what you'll notice here is if I hit graph, I want you to tell me what you notice about the n behaviors of that graph. So on the left side it goes to up, right? And as you move right, it also goes what? Up. So the n behaviors go in the same direction. That's what I mean by n behaviors. Okay? Now, scenario 2. What if your function had an odd degree? Okay, so let's write that down. Scenario number 2. We have an odd degree. Okay. Well, I want you guys to make a prediction. If even degrees go in the same direction, what do you think odd degree functions are going to show on the graph? Good. So we're going to write down odd degree functions. Their n behaviors go in opposite directions. N behaviors go in opposite directions. So in other words, we're looking at what happens on the overall of this graph. Okay? So let me give you an example. Graphing calculator, right? We're going to type in x cubed, odd degree function. So you just go to the y grid at the top corner, and then you just type in the x buttons right next to the green alpha button. Right there. Okay? And what's kind of neat about it is, like, if I type in x caret 3, x raised to the third power, odd degree function, right, and I hit graph in the upper right hand corner, what you're going to see are the characteristics of that polynomial. Right?
That's nice.
It's, if you move left on the graph, where does that graph go to? It goes down, right? And as you move right on the x-axis, where does that graph go to?
Right.
So notice the n behaviors behave as in opposite directions.
Yeah.
Okay? So that's the first thing I want to pick up on. Odd degrees go in opposite directions, even degrees go in the same direction. Okay? Now, let's look at what happens when the function has a positive or negative leading coefficient. Okay? So, what I want to do is, this is kind of wordy, is the function is a positive or negative leading coefficient. Just erase this, or get rid of this part right here. Because that's really what I'm looking at. What happens to the graph if you have a positive or negative leading coefficient? Okay, so I want you guys to analyze those situations. Okay, so now let's look at scenario 1, which has a positive LC. It's even and has a positive LC. Which direction are you thinking the end behaviors are going to go?
They're gonna go out.
Up or down? Up. So let's start with that. So if it's positive and it's even, I want you to write down that the end behaviors both go up. That's important to understand. Both go up. Okay? If it is negative, so if it's even and it's negative, okay, so, and there's a negative leading coefficient out front, so we're just going to say even with negative LC, then we're going to say the end behaviors both go down. They both go down. That is important to understand. If you have an even function, and you got a positive LC, so right, this guy is the positive LC, right plus LC right here. I forgot to mention that. They both go up. If you got a negative LC, they both go down. That's important to see. Okay? And I want to show you guys that even from the graph. Okay, so if I go back to the graphing calculator here, all right, and I check that, let's type in positive x squared and then negative x squared. Okay, so we got x squared for the first one, and then the next one we'll put negative x squared. Okay, so notice, look at the two graphs, guys. Here's the first one. They both go up. There's the second one. They both go what? Down. So the negative LC, the negative leading coefficient, would make it go down. Okay, both of them. Okay. Now, what you got to be careful is, what if we have, let's write down scenario 2. What about odd functions? So let's write our two situations. Okay. Let's say the LC is positive, and then we got the LC being negative. Now let's look at those. Okay. Well, if I got a positive LC for an odd function, let's go ahead and type that in so you guys can see that. Let's put like 1 out front, and then we'll make it 1x to the third. Okay. I want you guys to notice, if I graph that, a standard odd function, they still go in opposite directions, their end behaviors do, but it always goes from negative to positive infinity, from left to right. Okay, so what we would say is your end behaviors, the end behaviors go from negative infinity to positive infinity. So that's the direction it goes from. Okay, and that makes sense because you can see you go from negative on the left to positive on the right. Okay, now I want you guys to tell me what would happen if I put a negative out front of this equation. What do you think what the end behaviors are going to do? They'll still go in opposite directions, but is it going to go from negative to positive? Exactly. It's going to reverse it. It's going to go from positive infinity down to negative. Let's show you, just so you can trust me. All right? So if I got a negative out front, and then I do x raised to the third, and then graph it, notice exactly right. See how it starts from the left side from positive infinity, and then to the right side it goes to what? Negative infinity. Very good. So all that does is it reverses the end behaviors. Okay? So we're just going to say the end behaviors go from positive infinity to negative infinity. Okay, so I think that's important to understand the differences between even and odd functions, and when you got an LC that's positive and negative. Okay, now another thing that comes up in polynomials that we want to pick up on here is this idea of our real roots. Underline that, guys, that's important. Okay, the number of real roots just represents the number of times the graph touches the x-axis. So let's jot that down. This is the number of times the graph touches the x-axis. All right. So let me give you an example of looking at the number of real roots. Okay. On the side, I'm going to draw a little graph. And I want you to tell me, just by the graph, how many real roots it has. Okay. So let's say a graph curves like this and then it goes back up. How many times does that graph touch the x-axis? 3. So we're going to circle those 3 spots. Those are real roots. That's another characteristic that you want to look for in polynomials. Okay? Now, another little trick to pick up on, guys, is what we call the minimum degree of a function, just based off the graph. There's a nice little trick I want to show you guys. Okay? It turns out that if I look at a graph, all you do is you look at the number of turns, and you add 1 to it to get the degree.
So if you can't see the x-axis.
So tell me this, look, just on this example, right? How many times does it turn?
3 times.
So once and then twice. It's got 2 hills, right?
Yeah.
So you have 2 turns, and then you just add 1 to it.
Yeah.
So what type of poly is that? Well, what do we call a third degree?
Cubic.
A cubic. So I could give you a graph, and you guys could say, oh, that's just a cubic, because it has 2 turns. All right? So let's write our rule down. This is a trick. All right? So all you do is you take the number of turns plus 1. That's it. I always tell students, all it is the number of turns plus 1. So I could give you a graph with 7 turns in it, and what type of poly would it be? An 8th degree poly. All right? So that's an important skill to be able to see. Okay? Now, the last thing you're going to want to know for any poly is this concept right here. What is the limit as x approaches positive infinity? That is a fancy wording, but it's a simple concept. Okay? So then let's actually go back to this same graph. All that means, guys, is as you move right on the x-axis, what's the graph doing? So in other words, if I draw an arrow in this direction as I move to positive infinity in the x-axis, what's the graph doing? It goes up. So all you do is you say it's positive infinity from that example. So all this means is, let's write this down. As you move right on the x-axis, you identify the end behavior of the graph. Okay? You identify the end behavior of the graph. That's all that means. So when you see this terminology here, what is the limit as x goes to positive infinity? You're talking about on the x-axis. So as you move right, what's the graph doing? Okay? Now, what do you guys think this terminology means? So as you move left on the x-axis, as I go this way, what's the end behavior doing? Very good. So that's the only thing that's different here. So let's write that down. As you move left on the x-axis, you identify the end behavior. So I'm going to teach you guys how to do these characteristics for any graph. So we're going to identify all these concepts in each graph. Okay? So now it's the point where we just put it all together. Okay? So the first thing I want you guys to do is I want you to look at this graph right here. And I want you to tell me if it's even or odd. Odd. Okay, let's write letter A, odd. So for each question, we're going to answer for each graph. Okay? So why is that one odd, guys? How do you know?
It goes down.
The arrows go in what? Opposite directions. That's the first thing I got to recognize. It's an odd function.
So if the arrows go in the same direction,
It's even if they go in the same direction. Very good. Okay? All right, question 2, or letter B, says, is the leading coefficient positive or negative? All right, now remember, if it's positive, it goes from negative up to positive infinity, right? So this one would have to be what? Negative. So there's a negative out front. So we know there's a negative out front of this polynomial. Okay? Question 3. How many real roots does the function have? So let's circle where it crosses the x-axis. So we're just going to write 3 of them. 3 real roots. Okay? Now, letter D says estimate the real roots. So you just put coordinates in for it. And it doesn't have to be perfect. But for those 3 circles, let's estimate what coordinates those would be. So that point looks at about negative 2.5, 0. So one of them would be at negative 2.50. Okay. You guys tell me what this one would probably be? Negative 1, 0 is another real root. Okay. And then which one do you think this one would be? Yeah, I mean, it's close to 3. So I would say like 2.750. Let's just estimate. And it doesn't have to be perfect, guys. It's just what you think. Okay. In Algebra 2, I'm going to teach you guys how to really get them. But for now, it's just recognizing it. Okay? All right, letter E now. It says, what is the minimum degree of the function? So all you do is you look at the number of hills, or turns, and you add 1 to it. So how many times does it turn? 1, 2, 3, 4. So you add 1 to it. So how many turns would this be? Or, what would the degree would be? 5. So we would say a 5th degree. What's the name of a 5th degree, guys? Good. So we would say it's actually a quintic. So we know by the graph it's a quintic polynomial. Okay? Now, the last 2 questions, you got to understand what they're saying now. So let's write this carefully now. What is the limit as x approaches positive infinity? So in other words, as you move which way on the x-axis? To the right. What's the graph doing? It goes down. So all you do is you say it's negative infinity. So what you say is f of x, the graph, approaches negative infinity. You just write it, or you just write negative infinity, either way. Okay? Now, I want you guys to tell me what letter G would be. What is the limit as x goes to negative infinity? It goes up, right? So as you move left on the x-axis, the graph goes to positive infinity. So what we would say is f of x, the graph, approaches positive infinity. So that's how you write that in a math form. And if you guys just wrote these signs here, that's totally correct. Okay? So what I'm going to do, let's do a few more together. I really want to make sure you guys got this before we do our assignment. Okay? All right, flip her over. All right, here's 3 graphs. We're going to do one at a time for each of them. And then you guys are going to be kicked butt with this. All right? Okay, we're going to answer letter A for all 3. First graph, even or odd?
Even.
Odd. Why is that odd? Good. So see how the arrow's going opposite direction. So it's odd. Okay?
Yep.
Second graph. Even. Very good. Third graph. Odd. Very good. So just do that first, one at a time, guys. And you'll kick butt with this. Okay? Alright, second question. Is the leading coefficient positive or negative? So now let's look at that. Okay? That one, since you go from negative to positive, is still going to be what? A positive LC. So that's a plus. Okay? Alright, what would it be for this one? They both go up. So it's positive. Okay? Now, if they both went down, the LC would be what? Negative. So be careful there. Okay?
Does it just matter what the one on the far right is?
Both. You look at both. You look at both. See how they're both going up? And that means your LC, the leading coefficient, is positive.
Yeah, but like the only way it can be negative is
If you had if they were both down,
yeah, so
it would be negative. Okay? So like, what about this guy? What would your LC be on that one? That's still positive. Very good. Because it's still going from negative to positive infinity across the graph. Very good. All right, letter C. How many real roots does the function have? All right, so this one has how many? 3. Very good. Okay, let's circle those 3 spots so we know where those real roots are. Okay. All right, tell me how many this one has. 2. So there's 2 spots in which it touches the x-axis. Very good. And how many does this one have? 3. Very good. So we'll just, and this is how I want you to do your assignment, just like this. Just answer each question the same throughout each graph. Yep. All right, so letter D, let's look at this carefully. Estimate the real roots. So now we just got to put the coordinates down for each real root, right? So, all right, let's estimate on this guy. So I'm going to have Blake tell us what he thinks. Looks like negative 0.750. What would this middle one be? 0, 0. And then what about this one? 0.75? Yeah, there we go. So there's your 3 coordinates. 0.750. Okay. All right, now let's do the same thing for the second graph. Let's find the real root coordinates. Okay. Am I moving too fast, guys? Okay. I just want to make sure I'm not going too fast. So tell me the coordinates on these. Good. So negative 2, 0, and what? And 1, 0. Very good. Okay. All right. Caden, tell us the coordinates of these three zeros.
So negative, let's say 2.5.
Yep.
And 0.
Okay.
And then negative 1 and 0.
Yep.
And then 2.75.
That's totally fine, and it's really up to you. Because in Algebra 1, that's all I'm going to expect out of you guys right now, is to estimate. Okay? We'll learn how to get precise answers later. Okay? Actually, write down the coordinate, because that's important to recognize that. Okay? Good point. All right, letter E. This is important skill here. Tell me the degree of each graph now. So look at the first one. How many turns? 2 turns. So you add 1 to it. So what's this called? That's a cubic. Very good. So now we know that's a cubic graph. Okay? That's a 3rd degree. So it has 2 hills, and you add 1 to it. Okay? All right. Look at the number of turns on this graph. 1, 2, 3 turns. So this, what's the name of a 4? Quartic. Good. So the name of this is a quartic. Okay? 4th degree. And let's look at this one now. 1, 2, 3, 4 turns. So what's 4 plus 1? So what's the name of a 5? Good. So this is a quintic. Good job, guys. I'm really impressed. Now, if it's anything past a 5, what do we say? Just say whatever degree it is. Okay? 6, 7, 8, or whatever. Okay? All right. Now let's look at the end behaviors now. Let's look at letter F. What is the limit as x approaches positive infinity? All that means, guys, is as you move right on the x-axis, what's the graph doing? So we'll just say plus infinity. Okay? So let's look at all 3 graphs and look from the right side first. Okay? Tell me what happens on this one. What's the limit as x approaches positive infinity? So what's the graph doing? Going up to infinity again. So that's a plus infinity. Okay? Tell me what this one's doing. Plus infinity. So in other words, all you do is you put the sign, the infinity sign. Okay? So now we're going to go the other direction. The last question says, what is the limit as x approaches negative infinity, right? So all you would do is you move left on the x-axis. The graph goes to negative infinity. So that's all they're asking for is what's the graph doing as you move left. Okay? Tell me what this one would be. Positive. Good. That's positive infinity. tell me what this one would be.
Negative.
Negative infinity.
That's good.
Raise your hand if you can do this, you think you can do this on your own. And give me out of 10. 10 on your fingers. Alright. We're gonna do it. Alright, so here's what's gonna happen.
I have a 10.